Yeah, I saw Travel is the first guy get on here. He's even been here earlier than me. He probably never sleep, always working. Hey, Yifan, you skipped my class yesterday? I call your name and you didn't answer. Yeah, don't think I cannot catch you if you skip my class. Okay, it's almost there. Do you guys have any question? Oh, you guys just all good. Everything is so simple, easy, no problem at all. Yep, go ahead. Round up, when you're rounding, it's there's a general rule for rounding. If you have a 10.4, if you're rounding, it's equal to 10. If it's a 10.5, when you're rounding, you can round to 11. So depends that number. If it's 35, 31.93, depends on how many decimal point after that you're rounding. It could round to 3532 if you round to the whole number, or you round to 35, 31.9. That's for the 1 decimal point. Let me take a look at the working sheet. They round it differently. Okay, so when they round to base 10 register, they just round to the whole number. 35, 31. In this case, they might just let me see. It's a 17.8. What's the original number they give to you? Temperature, okay. Temperature is 39 degree. And the temperature is between -30 to +50. That's a working sheet given to me by another instructor. I'm not sure. Maybe he run down the everything. So let me try once. Okay. Yeah, he run down. Usually, when you're rounding, just follow the thing I gave to you. If you have a let's say 35, 31.93, if you round to the whole number when you're rounding, if this digit is larger than 4, you round up. If it's smaller and equal to 4, you round down. Another question, I think from Lucky. Do you need to know static or dynamic from a module 1? Are you a good student?
Rick, on rounding up and rounding down, I've always been taught that 0.5 was the point which you rounded up.
Yeah, so if larger than 4 is a 5, you round up.
Okay.
Yeah, if it's a 4 and below, you round down. So if you are a good student, then you don't need to worry about that static or dynamic from module 1. If you 0.41, you round to the whole number, you round down. Because 0.4 is smaller than 5, so equal or smaller than 4, you always round down.
I also had a question with the signal-to-signal conversions.
Yeah.
I used 0 to 10 volts to work out my conversion value to the controller base 10 value.
Yeah.
It's pretty simple because it's 0 to 10. But I couldn't figure out how to do it from 4 to 20 milliamps. Is there a way?
Because the 4 is you don't have a 0 down there. You have a 4, so everything you have to subtract 4, like when we give you in the formula, or when they even in the book, you have to take that 4 into consideration. You can't just ignore that 4. The 4 have to be in your calculation.
So you would divide 4096 by 16?
4095 is now 4096 because you have to subtract 1 digit.
Yeah, sorry, yeah.
Yeah, divide by 16, yes.
And then you would, okay.
Yeah, and your amps also have to subtract by that 4.
Okay, that makes sense. Thank you.
You're welcome. Yeah, so just be careful because sometimes you have 0 to 10 volts, sometimes you might not. You just have a 4 to 20 milliamps. So can't just always stuck with, like the working sheet I gave to you is they give you both, but what if they don't have 0 to 10 volts output, right? You got to do the calculation based on 4 to 20 milliamps. Anyone's question I am missing? Because you guys typing sometimes it go fast, so I couldn't see.
I have a question, Jack.
Yeah, go ahead.
I was going through the notes from yesterday or the day before, I forget. But anyways, it says the main advantages and disadvantages of current signal transmission systems.
Yeah.
So it has it as an advantage that it can be transmitted over long distances without losses.
Mm-hmm.
But it has pretty much the exact same thing as a disadvantage as well.
So
it's a limit to the length, and you end up with losses if you have too much length in devices. So it's like, is it an advantage or a disadvantage?
It depends on the real situation. So if you have a current source, when they compare to a voltage source, right? So the voltage usually we use as a 0 to 10 volts. The current is 4 to 20 milliamps. This one, because as long as your power supply can supply power or whatever, right? You can go far longer than the voltage source. Because for the voltage, if I have this is my transducer or transmitter, and here's your power supply to supply the power.
Mm-hmm.
And then I have maybe have let's say 2 equipment down here. So those equipment will be parallel. You have a wire will have a voltage drop. So even at 0 volts, you have no current. That's fine. But when your output should be 10 volts, you will driving a current through, and this wire resistance will have a voltage drop. So you have to take into the consideration the power supply have to be able to deliver 10 volts around here, while you have a voltage drop of maybe 1 volt or 2 volts, right? And for this one, because each those equipment, they have an internal, we call the internal impedance or whatever, they will draw a current. When they draw a current, they also will have a voltage drop down there, and then you want to keep the 10 volts here. So it will be slightly harder to plan out how far you can go with the voltage drop on the wire. But for the current source, as long as your power supply certain amount of voltage, because most of the time you will have a series circuit, your equipment is always connect down in series. So you do a calculation for 20 milliamps, and you have a wire resistance. As long as this power supply can give the transmitter enough voltage to make this thing work, you will have a voltage down here, and your voltage drop on the wire, voltage drop on each of those resistors is big enough for the power supply to supply. This wire can go pretty long. So
Okay.
like we said, you can go 1 mile, like the calculation we did, half mile. But for voltage signal, you probably usually is less than 300 feet. You will not go more than that. The common one for voltage source is usually is around 100 feet. So when they compare this to that, they said, okay, the advantage is this one can go far away.
Right.
But at the same time, because you need that 20 milliamps, if your distance go really long, your wire size control wire, right? You're not going to go use very large size control wire. So if the resistance here, and if you want to add in some extra equipment or have voltage drop down here, you like the example we did the calculation yesterday. If all those calculation to find for the voltage drop everything, it's sometimes hard to find a power supply will be able to give you the voltage you required. Like yesterday, we calculated 24 volts power supply is very common in the industrial control, right? Then next one maybe 48 volts. But if you calculate between, let's say, 32 volts, that's the required one, you probably really hard to get a 32 volts. Right. So for that limitation, because 24 volts is so common, and you have to be careful. If you have more equipment, that will be more voltage drop. So you have to keep the distance to a certain limitation. You cannot just go, oh, I can go wherever, how far I want. That's not the case. That's why this one is in both as advantage and also disadvantage.
Yeah. So basically you can go long distances, but only if you have the adequate power supply to do it.
Yes.
Okay.
That's the idea.
Okay. Thank you.
You're welcome. Yeah, sometimes certain thing in this automated control is kind of like a yesterday I even found that the guy he wrote the book like today I'm going to show you something. We go to module 3. The guy wrote the book. He even made a mistake in there. Yeah, John gave a really good idea. So when you have the formula, write down your brackets down there so you don't make a mistake. Anything else? Nope. So I guess you guys are all good student, are gonna have a very good mark on the exam, right? Yeah, go ahead. Review day, it depends lots of time because we have a pretty tight schedule. For certain topic, you might have more time, but a certain topic you might not have lots of time. So if I finish the material faster, we might at the end have some review time for you. But if we finish the material, some topic we just have to finish right to the almost last minute. I will try to usually give you at least half hour for answer your question, but review days is if you look on your schedule, at the end you will have an IP preparing day, or sometime you will have a science study time. Other than that, yeah, usually we don't have review days. Okay, I think Tristan sent me a question. Probably can make this one a little bit larger. Can you guys see it? Okay, I think that's good enough. This is probably a temperature sensor, the resistance, the output signal. So this is the temperature sensor, terminal, transmitter, everything. Where is the chat? Okay, so refer to the drawing that show calculate approach at 11.4 degree. Because 11.4, you can say is somehow between 0 and 25. So I will just take that two number to do the calculation, and I can just take in between the temperature and this resistance. So sometime in your work, you might not have all the like a maximum number, minimum number. You just have to pick any of the two number. You can do the measurement. So 0 to 25 degree will be one side, 100 to 109.9 ohms will be my second part, and they want you to find out 11.4 degree. So I will go, my resistance going to equal to 11.4 subtract 0 because minimum is 0. 25 subtract 0. That's my temperature. Then the resistance down here will be 109.9 subtract 100. My minimum is 100 down here. So 11.4 times 9.9 divided by 25. So this portion gave me 4.5144 plus 100 is 104.5144. And from here, I'm going to choose in 104.5 ohm. Yeah, or another way you can see 11.4 degree is between 0 and 25, and the resistance, it will be between there. So for this question, even you don't do the calculation, you can just choose a number in between there. Sometimes it's a little bit tricky. Usually for this type of question, if you want to get the answer really close, you will pick the number. You will pick because 11.4 is between 0 and 25 degree. I will pick that to temperature degree. Especially later on, we're going to talking about those temperature sensors. A lot of time they are not so linear. So if you pick between 0 to 100, and you're picking 100 ohm, 139.3 ohm, you might not get an answer so close. That answer your question? You don't have to thank me.
Hey Jack, so you're just saying for that you can use basically any of the numbers from the table as your range, as long as you keep everything. I can't think of the word, but
yeah, as long as you can pick in what's the two ends and put that number in there to do the calculation. You can pick anything. It will actually give you the answer, but the answer might not be so close as I did the calculation here between these 2 degrees.
Okay.
Yeah, it will work. You might calculate a number 105 or 103, something like that.
Right.
We good? Anything else? Speak up. or hold your breath forever.
Can we do one with negative temperature, please?
You mean like the working sheet type
Yeah.
of question? Sure.
Yeah. Just the second one on there. It's just -10.
Yeah. So in that working sheet question is the temperature is from -30 to +50, right? So that's your two ends. If the temperature is, let's say, -10 degree is where they give to you. We're gonna do milliamp calculation because that one usually is a little bit tricky. So you just consider this will be your minimum value, this will be your maximum value, and this also equal to your zero value down there. So put this in your formula, -10 subtract -30, you got to put all the negative sign in there, over 50 subtract -30, right? So that will be the temperature range. That will be your actually your measurement subtract the zero value. Your amps is between 20 milliamps subtract 4 milliamps. Then at the end, you have to add the 4 milliamps down there. So the top -10 subtract -30 give you a 20. The bottom 50 subtract that give you a 80. Then you times a 16 milliamps plus a 4 milliamps. That will give you 4 plus 4 is 8 milliamps.
Perfect. Thank you.
That makes sense?
Yeah.
Okay. Yeah, so just whenever you're putting those numbers into the formula, you got to be careful if with negative number, you have to take the negative sign in there. Okay, anything else? You guys are really quiet. Okay. Now we get on to, so in module 3, we're talking about pressure transducer. Module 4, we're talking about flow transducer. Module 5, we're talking about temperature transducer. Because there's hundreds of thousands different type of transducer in there. We try to categorize them based on where we're using them, but also depends on different transducer. It's not an electrician's job usually. Usually is either an engineer or the guy designing the system. He's gonna picking the transducer for the job. We as electricians, we mostly do the maintenance. If they usually came with the manual, we will do the installation, and the manual will give you the installation, and maybe sometime it's broken or something, we're gonna do the change. So we not gonna be required to, we need to have a little bit of basic idea how those transducer works, but it's not our job. Even if you just are engineering doing those things, it's not that guy's job to designing all different type of transducer. You have to working specially in that field or in that designing firm to try to design those. So our job is to use them. We get a basic understanding how those things works. That's the most thing, right? And also for you guys, it's your first time have a contact with those type of topic. So we will tell you, or I will tell you, what you need to pay attention to, what is totally don't need to worry about too much. So first, if we want to measure pressure, we have to know what's the pressure. So pressure is measured as a force per unit area. I'm not sure if you learned this in your high school or not, because I didn't go to school down here for my before grade 12. So did you guys learn this in your high school anywhere? Or you guys just all like the, yeah, you learned that, right? Good, thank you. So what if I told you this is important to know, or at least for this course, because that's considered a basic idea. So the pressure is measured as a force per unit area. In here, they give you an example. They call that 1 psi. P means pounds per square inches. So 1 psi is equal to, you put a 1 pound of force in an area of 1 square inches. Did you guys get what I say? You have to know this. The pressure is measured force per unit area. If you don't get this right, someone going to be punish you. For the pressure, there is a lot of unit. You have an imperial unit, you have a metric unit. Some of them use inch of the water, or some of them use centimeter of the water, or some of them use inch of the mercury, some of them use centimeter of mercury. So it's all different type. In the metric unit, they use the Pascal. Pascal is if you have 1 Newton of the force applied to 1 square meters. So Pascal is a really smaller unit. But they give you a table, and do you have to remember this table? Unless you got a version F exam, you don't have to remember anything in this table. It's just for information only. If you have this book, and I'm not sure how much of you're gonna be getting to the industrial field. Maybe you're still young, and now you want to just working on construction side. First goal is to become a journey person, right? So later on, when you're getting older, or when you have the chance, you want to jump into the industrial field, you might need working on something with those pressure sensor or whatever. And that time, if you still have the book, or maybe that time everything changes, everything is on your cell phone now. You never know, right? So this is a table in your book. Don't have to really remember anything from the table. And I'm not gonna ask you to do any conversion calculation by using this table. Pressure measurement scales. There are 4 basic scales. One called the gauge pressure. Gauge pressure usually is we use an instrument as a pressure gauge to try to do the measurement. Absolute pressure is they have a reference to the 0. Like you can see at the bottom here, instrument with absolute pressure scale are reference to the absolute 0. a complete absence of any pressure. We they say complete absence of the pressure is because when we live on the Earth, there's a atmospheric pressure. So the air on the surface of the Earth, we also have certain pressure at any point. The absolute pressure is starting the zero, absolute zero is at a vacuum. So the gauge pressure is taking after the air pressure on the Earth's surface, but the absolute pressure is starting from a vacuum. Differential pressure is usually when we try to measure the flow of a liquid in a pipe. One way of measurement is we can take in the differential pressure between 2 points. We can figure out how much the liquid or gas is flow in the pipe. So that's something we're going to talk about slightly later. Vacuum pressure is just if you go outside airspace, you go to far away from the Earth's surface, it will be have absolutely no pressure. That's almost like a 0 point. Here, did you guys saw some red thing on top of this PowerPoint? So if you've been in my class before, you know what those red letters means in the class, right? So because the absolute pressure is a reference to the absolute zero, so this pressure number can only be positive values. But the gauge pressure, they use the atmospheric pressure as the reference point. So depends if your pressure is red means copy and paste to this group. Then your atmospheric pressure, you can take in two numbers. One is a 14.7 psi. Sometimes we use a 15. So it depends. That atmospheric pressure is always changing. It's not a constant value. The gauge pressure might be you try to measure something. We have a pressure higher than that, or sometimes they might have a pressure lower than that. So the gauge pressure, we have either positive or negative numbers. Another way, you better taking a picture. What did you mean by air pressure from the Earth regarding the gauge? Oh, we're going to show you down here. Because your absolute pressure is equal to the gauge pressure plus the atmospheric pressure. And if you see on your book, I'm going to show you also a video. So in your book on there, they're talking about here's your gauge pressure. Your gauge pressure, because when you're using a gauge to measure, you are using on the surface of the Earth. So that atmospheric pressure is always existing on the Earth's surface. So whatever the pressure you measure by a gauge, you always have a reference point as your this air pressure on the Earth's surface. It's you will compare to that, and it's always there. the gauge pressure, if the gauge reads 0, it's equal to the Earth's surface air pressure. Yeah, so from this picture they give you, this is a fixed propane tank pressure. The fixed propane tank, the absolute pressure is constant. They never change. But it depends on atmospheric pressure because the air depends on that time, the air density, the temperature, the humidity in the air. The atmospheric pressure will change. So the gauge pressure, if this air pressure is low, your gauge pressure will become higher. If the air pressure become higher, your gauge pressure will become lower. Okay. So pressure measurement scales. The pressure is always have a reference point when you measure something. There are 3 common scale. It depends on the reference pressure they used. One is the absolute pressure, and the absolute pressure is down here. Reference is as absolutely 0 or as a pure vacuum. So this is a 0 as the reference point. They use a complete absence of the pressure called absolute 0 as a reference. So the reference is a complete vacuum. There's no air, nothing, just like in the outer space. Because you will never have a negative pressure on the vacuum. So the absolute pressure reading is only positive. So those things, like it's also read in the PowerPoint. You have to have a good idea because you might encounter some question. We ask you which one we have a negative reading, which one is always positive. Those things you better will be able to answer them. So they have a special unit down here. They call it PSIA. It's pounds per square inch at the absolute. If the pressure measurement is taken at the atmosphere at the sea level, usually it will raise 14.7 pounds per square inch. This is not a constant number. It's changed slightly, not too far from this number. You could have a lower than this number. You could have slightly higher than this number. And on this drawing, you can see here is the atmospheric pressure. So they give you 14.7 down here. And the vacuum pressure is going down. Absolute pressure goes up. Your gauge pressure is from this reference point taking up. Vacuum pressure begin at here and work its way down to the complete absence of pressure. So this is a different way in the United States. So sometimes they use inch of mercury. It's 29 inches. The vacuum pressure at sea level we measure 0. So the vacuum pressure, we don't use them too much, and it usually is for scientific, for those science they try to do something. We only care about the gauge pressure or absolute pressure. The gauge pressure uses the atmospheric pressure as reference. When the sensor at the sea level, it records 0. The unit usually writes PSIG. G means the gauge. Misspelling somewhere down here. The measure is either positive or negative, depends if above or below the atmospheric pressure reference. The air inside a tire, so 30 psig, that's above the atmospheric pressure. So when they will give you some example to do the calculation. Negative gauge pressure indicating a pressure in pounds per square inch below atmospheric pressure. At negative 14.7, it's a fully vacuum. So you can see here is absolute pressure is at 0, but the gauge pressure, if you're taking the gauge pressure reading at this, those are equal, is at this point. So that's 14.7 psig. The conversion, to convert the gauge to absolute pressure, you need to add the atmospheric pressure value on top. So this is also a very important point. You might have a question ask you to do this type of calculation. Here they put a red mark on here. Also, to convert the absolute to gauge pressure, you have to subtract the atmospheric pressure. So these two calculations, you need to be able to do it. Okay. Go back one page. Oops. Okay. Yes, so basically the calculation, I think they give you the formula. So A or B? A, good. A again. We're just gonna use 14.7 for this 29.7. Oh, sorry. We should add 14, so 39.7. Fan, you're gonna lose a mark on your exam. It's okay. I made a mistake too. I didn't think about it. Don't need to worry about this. Okay, finish this one. So this formula, you might have to do a calculation. It depends, right? So I'm not gonna guarantee everyone will have this type of question because the question is pulled from a question bank, but I try to cover for most people. You might see this question, you might not, but you'll never know what type of question you're gonna see. I never know. I'm gonna be randomly pick up the question for you, but this will be important to know. You will, yeah, in the online exam, usually they will have a question bank for the exam. Let's say, just for example, you have a module 1, right? Everyone will get 10 questions from module 1, but the question bank for module 1 maybe have a 20 questions or 30 questions. So you will be randomly picking 10 questions from that bank for everyone's exam. So some questions you might have the same, but some questions you might have a different. But when the instructor making those questions in the question bank, he will consider make them equal difficulty. Just like a question module 2, you will have 19 questions. You have a 9 calculation question. The 9 calculation question, it's everyone will have them, but because for the calculation question, we can set pop up different numbers for everyone. So we set a number range. So you might get a question like a 50. Here we get a question in 40. Another person get a question in 30. So, but you will have all. We have that 9 calculation question. Another 10 question might be from bank about 15 or 20 questions. They randomly picking up. They are at the same difficulty levels. That makes sense? I can give you a version F exam. I can make a super hard exam for anyone, but I cannot pick in any easy. Okay. No, just kidding. I usually don't like to do that to. There's no point to fail the student. As long as they come to my class, you should pass the exam. Hydrostatic pressure, it's for measuring the pressure under a liquid. Because for any container holding the liquid, the pressure at the bottom of that container, it will be different at the different heights. The heights of how much liquid inside the container will make sense to so the height and the density of the liquid we we're deciding how much pressure at the bottom of the tank. And so it depends on, they use the term head to describe the height, and the hydrostatic pressure is called head pressure or hydrostatic pressure. The actual calculation depends on if you're using metric or imperial unit, it will be slightly different, but we're going to show you something down here. So this is some type of explanation about hydrostatic pressure. You have a container, you have a certain type of liquid in there. The force produced by, it's called hydrostatic pressure. The general form is because it relates to the height and the density. That's why that's the two important fact you got to be considered of. So you could measuring the liquid level or the height of liquid by putting a pressure at the pressure gauge at the bottom of this container, and if you know the density of the liquid, it will tell you the height of this liquid level in the container. They use water. Pounds per square inches. This is using the imperial unit. You don't need to worry too much. I'm not going to use that to do the calculation. So because we know the pressure and we know the density, we can find out the height of the water or the level of the water in there. But in this one, if you have a totally enclosed container, because the gas or anything on top or the airspace, the water or the liquid, usually you cannot compress it. But the gas, usually the air, you can compress it. When you compress the air, they will changing the pressure on top. You're not going to have the atmospheric pressure as your gauge pressure, the reference point anymore. So that's why they said for this reading, it should be taking an open container. The open container, on top of that, that would be the normal normal pressure for air. Measurement taking in a pressurized vessel, the pressure created by the airspace, we adding to the pressure to the liquid cause force reading. That's why. So for this question, what are you gonna choose? Both. That's right. A, it's the open one. You could do this, or you don't want to do it. It doesn't matter. We're not gonna ask you to do this calculation. 75. Yeah, you're correct. So that's a small program to show you some basic thing about this hydrostatic pressure. Excuse me. For the liquid, the pressure will be exerted on the container which contains it. The gas, if you have a closed container, because you have to hold the gas inside, the liquid, as long as you hold the bottom, you're not going to go anywhere. It might evaporate a little bit, but the gas, you have to totally enclosure the container. And if you put in the gas inside the container, the pressure will be exerted on all the wall holding it. So the pressure for the gas will be uniform on all sides, but the pressure on liquid, it will be varies. It will be greatest at the bottom and zero at top surface. At the bottom part, you don't need to worry about. We're not gonna looking at those things at all. Pressure sensor. So we consider measuring pressure. When we use gauge, it's equal or greater than the atmospheric pressure. Sometimes depends on the equipment you measure and the inside pressure is. How does it work? To measure the pressure on a surface area, the resulting force causes the mechanical deflection or displacement. So that's talking about how we're gonna those pressure gauge or pressure transducer gonna be built up. For deflection type of pressure sensor, we need three components. One is called a primary element. One is called a secondary element. Then we have a signal conditioner. The primary element is converting the pressure into a proportional mechanical displacement. So we will use the pressure inside, whether maybe the pipe, maybe the container, to causing something moves. And it depends on the movement or displacement of that, we know how much pressure in there. So the pressure will be causing proportional movement for maybe a play or anything. Secondary element is we're going to converting those mechanical displacement or movement into electrical quantities. The most common is we can change those movements. We might have a variable resistor, so we can change to the resistor value, or we can change use that to change to the capacitor variable capacitor, because if we can change the plate, the distance between the two plates, we can change the capacitance. Also, we can change those as if we have a coil, we have a core, we can change those movement into the movement of the core, just like yesterday we talked about linear, variable, differential transformer. If we move the core in there, we can change the inductance of those coils. So those are usually considered secondary element. We're going to convert in the mechanical movement into electrical quantities. Signal conditioner. So then we're going to change those electrical quantity, doesn't matter, resistor, capacitor, or inductor, or sometimes even you can change voltage or something, into a proportional signal. So we're going to convert to a useful signal, can be used for other instrument like a controller, a PLC, or anything, right? So signal conditioner we're talking about yesterday. The deflection type pressure sensor have 3 common types: Bourdon tube, bellows, and the diaphragm. A Bourdon tube, the picture will look like this. The pressure getting in there, it's coiled tube, and the pressure will make this tube to stretch. So it will try to extend, try to become straight. So depends on the pressure you put down there, it will make that thing changes. And the Bourdon tube usually is you can use from a very low to very high pressure measurement, depends on the one you're choosing. So if you have a read Bourbon, what? You're drunk in my class? You can read to very high pressure. Usually for very high pressure application, they always using the Bourdon tube. Bellow usually just used for pretty low pressure measurement. It's if you have some kind of pressure in here, this is a corrugated sides down there. They will extend this bellow farther away if the pressure is high, if the pressure is low, because those corrugated frame, they kind of have like a spring action in there. When the pressure is low, they will try to go back to the left side. When the pressure is high, they will extend to the right side. Diaphragm is also, it can measure a pressure slightly higher than the bellow, but also the pressure measurement will be below the Bourdon tube. They contain one side to wherever the pressure input is. Then they will make that metal. This is also look like those corrugated metal, like the side of the bellow, but they are much stronger. So the displacement for this one is now going to be bigger like the bellow, but the pressure we causing this diaphragm, we extend or contract a little bit. So depends on that movement. That's all causing a mechanical displacement or movement. Then this is all the primary measurement elements. What if I told you this page, these 3 diagram is very important to remember? So you might have a picture on the question showing you maybe a Bourdon tube, or maybe a bellow, maybe a diaphragm. They ask you what's the type of the pressure measure element is. This Bourdon tube can measure very high. The bellow usually is pretty low. The diaphragm can measure higher than the bellow, but you can also use the diaphragm for the low pressure. Yes. So on the book, you're talking about how I think they're talking about the burden tube can measure up to 10,000 psi. The bellow usually is 100 psi, and the diaphragm can measure a few hundred psi. But remember the picture, how they look like, and what's the name for each of them. Yes, that's right. So you can have a burden tube to measure only few psi. You can have a different burden tube to measure up to 10,000 psi. But you cannot use one to measure 5 psi and 5,000 psi at the same time. They have to be different. Do you need to know those amount? If you get a version F exam, you probably have to know the amount. Other than that, you don't. Yeah, just like I said, remember the picture, how they look. I think those English words make sense down here, right? Why this called a burden tube, why this called a bellow, the diaphragm. Okay. How does one get a version F? Like E-fan, if you skip my class, that probably you're gonna get a version F exam. Secondary element. The secondary element converts mechanical displacement from primary element into electrical quantity changes or signals. So in here, the whole thing together will be a transducer or a transmitter. The pressure causing the bellow to move. The other end of the bellow is contained on this is a variable resistance, and this is a resistance. You have this is more look like I think called a rheostat, and then you have a calibrated spring down here. So you can measure. You probably have a power source inside. You can measure the resistance in here because this is a jumper on this side. So when you measure the resistance, you only measure from this point to wherever this wiper is. If the pressure changes causing this wiper move left or right, your resistance will change, and through the signal condition unit, they can give out a proportional signal. This one is 4 to 20 milliamps. This is using variable resistance. This is a diaphragm by using a pressure to change the distance between these two plates. So you could have a AC signal down here, try to measure the capacitance. This is very common. It's not very common to see. We usually, in our trade, we say the C equal to K times A over D. The K is a constant, we call the permittivity, but don't need to worry about that too much now. Just the capacitance is based on the area of the plate over the distance between the two plates. So if the pressure causes this capacitor plate to move, so when the plate move close, your capacitance will become larger. When the plate move farther away, your capacitance will become smaller. So they can based on measure the capacitance down here to give you a proportional signal for how many pressure is in there. This is called a variable inductance. So it's also a diaphragm primary elements. The pressure causes this to move. The diaphragm is attached to an iron core or movable core. And you have a primary coil, you have a secondary coil. It depends on how much voltage going to induce on the secondary. If we know the movement of this core, because if your core is more close down here, you will have for sure induce higher voltage because the permeability increase. So the secondary element just converting the movement from the primary element to some electrical quantities. We're talking about resistance, capacitance, inductance, and we can, by measuring those electrical quantity, then through the signal condition unit, give us standardized usable output form. Do you guys want to take a break now, or you want to take a break later? Good. Okay. Now it's 9:15. So we're back at the 9:30. Need to make a transducer. Now you need a big tank. Okay, see you guys in a bit. Okay, are you guys back? One thing on this book, I think the author might made a mistake. It's on page 306 in my book. It says 1 pound per square foot equal to 144 psi. I think he put it in backwards. It should be 1 psi equal to 144 pounds per square foot.
Sorry, what page is that?
I think page 306, 3-6 on my book. It's right above the pressure sensor down there.
Thanks.
Yeah, your one might be, my one is in July 2019. If you got in January 2020, your one might look a little bit slightly different than my one. Okay, so there are different ways we can measure the liquid level in a container. So we use a differential pressure transmitter. They usually measure the difference of the pressure between two areas. Liquid level in a tank, if the tank is closed. If this is a closed tank, we have the liquid level up to here, but we don't know if the empty space above there, those gases or airs got compressed or not. So we cannot just based on one sensor down here try to measure the pressure from here, because if the pressure above there, the airspace got compressed, or you have any other type of gas is compressed, you cannot accurately tell from this pressure to tell the liquid level down there. So you need two sensors. One is at the top to measure the pressure of those gas or air above the liquid. Then second sensor at the bottom of the tank to measure the pressure down there. Then you subtract the pressure measure from the sensor 2. Then you know you can calculate the liquid level down there. So here is a different pressure transmitter. You have one pressure sensor at the bottom, another pressure sensor at the top. This one at the bottom of the liquid for sure going to measure a high pressure, because that's not only the air pressure plus the pressure causing for this liquid. The low pressure just measure the air pressure on top of there. They use these two different pressure. Then they will know what's the head pressure, hydrostatic pressure caused by the liquid only. Then put that pressure into the controller transmitter signal conditioner. They can display
what is the real height of the liquid in there. Before we go there, I'm going to show you. Called a displacement level sensor. So one way of measuring the level of liquid, use a mechanical linkage, have floater. Those floaters, just like the floater switch when you guys learned in motor control. Because if the level of liquid changes, the floater will move up and down. That's where your floater in the motor control works the same way. So you have a spring connect the mechanical link, a scale. You can indicating what's the level in there. So that's the basic way, a simple way to display the liquid level in a container. And we can to make changes converting into electronic signal. So instead of using the scale, we can use a variable resistor, and with a supply source down there, then we can tell by the output of the voltage, we're converting that into an electrical signal. So this is adding a secondary element, so we can get a 0 to 10 volt signal output. But sometimes, because if you have a mixed liquid, two different types of the liquid, one is heavier at the bottom, another one is light on top. So if you have oil and the water mixed together, or some other type of liquid mixed together, but one is lighter, they always stay on top. Another one is heavier, always stay at the bottom. So then you cannot actually measure the bottom liquid level, because this floater is always will stay on top of the light liquid. So when these two liquids does not mix and have a liquid-liquid interface, the oil, water, slushes, special chemicals, we got to find different ways to measure them. Here's where they use a displacement level sensor. The sensor consists of a probe suspended from the spring scale, and the probe is called a displacer. It have some kind of weight in there, so you can actually sink into the measurement flow. Because this displacer, they have a volume down there, so when they sink into the liquid, it will repel a bunch of displace a certain amount of liquid in the container, and they will have a kind of force to try to acting on this displacer. And the force, I think this one is called
buoyancy.
Yeah, that's a fancy word, buoyancy. Sorry guys, some word is it's not easy for me to say it. So now, because it will sinking into the liquid, so we can actually measure the liquid level now. So now we have a mixed liquid, but because the light liquid is not going to be giving enough force on this displacer, the displacer actually we're sinking into the heavier liquid. And we have a signal conditioning unit down there. We can convert the output into a standardized electrical signal. Okay. So we finished this one. There's some visual. This called a YouTube manometer. It's kind of like a low pressure sensor. It's for visual indication. It's not gonna be converting into any type of transducer or transmitter. It's just for mostly they use for calibrate the transmitter or transducer, or for simple pressure measurement. They have two tubes down there. One is open to atmospheric pressure. So this side is open to the air. The air pressure gonna be here, and this is the connect onto the whatever the process you try to measure the pressure down there, and you have a scale down there. So you look at the difference between the liquid level. So you read on the scale there, you know what gonna be the pressure down here. They could use a glass tube or a plastic tube, it doesn't matter. And it's simple, it's a pretty accuracy, but it's not a transducer, it's just a visual device, just like the temperature meter or sensor in your house. They have some kind of improvements. They call it a well manometer. They try to make a big surface in this side. So when the pressure in the process causing the liquid to flow in there, because this tube is very small, but the well is very big, so you're not gonna changing the liquid level on the well too much. So you will make them more accurate. You can compare by reading on the scale here, because scale is calibrated at 0 down here. So how far this side the liquid goes up, you can just read directly from there. You consider the well, the liquid level is almost constant, not like the one before. This one, you actually have to read both sides the liquid level to find the difference down there as the pressure. But the one on here, you can just read directly from this scale. They have a inclined, this manometer. Just they make this side the tube because it's in an angle. So this one will become longer, and the scale will become more accurate. So because the scale can become longer also, so it become more accurate. Those one is mostly just for for the calibration of your transducer or transmitter purpose to compare the pressure or for visual use only. The liquid level measurement, because we're talking about, we know the head pressure down here, and if it's an open tank, we have a diaphragm in the center, and the pressure from the hydrostatic pressure will cause this diaphragm to move. Another side is open to the atmospheric pressure, so the air is coming in from there. The difference between these two, or how far it moved, we can use a level transmitter to send out the standard signal. Those just type of calculation. This is in metric. How we're going to calculate the Pascal is the density of the liquid times the acceleration of the gravitational acceleration and the heights. This is imperial unit. We're not going to ask you to do any of those calculations. This just basically give you an idea how they're going to be measured. And this is the example. You don't need to worry about. Lots of time in the industrial or even later on, like we talk about a term called the specific gravity. It's a ratio between any type of liquid, or even for the gas, they have that compared to in here, because it's a liquid, we use the density of certain type of liquid compared to the density of water, because the density of water is a standard value. So the compare of those two we give you a number. This number is called the specific gravity of whatever the liquid you try to measure down there. Don't need to worry about this. If you have a closed container, the pressure on top might be different than the air pressure. So now this time you need to put another sensor down here. This pressure sensor is a measure the pressure on top of the tank, and this is measure the pressure at the bottom of the tank. So this time, instead of use the air pressure, you're gonna use the difference between these two pressure to calibrate for the liquid level inside the tank. I think they also have a name called I think a DP cell, or called double pressure differential pressure. Yeah, differential pressure cell. This is the one we're talking about. We can use displacement floater, the force on stationary floater proportional to the liquid level around the floater. Then we have a capacitive probe. The capacitive probe, they can also use to censoring the liquid level, because those liquid usually is conductive. I have another one to show you down here. So we call a conductive probe sensor. It can use to detect the presence of conductive liquid at a certain level in the container. That's the house. And that's the controller. You have two electrical rods called probes. They put into the house at a different level. You supply AC voltage down there. When those are immersed in the liquid, there's a complete circuit because this is conductive liquid. Then you have a certain type of semiconductor switches in there. They will indicate that the liquid is above or below. The liquid level goes lower because you don't have the conductive liquid is too low. You have an open circuit. So they could have a multiple probe down there. The lower alarm, if the liquid level below that, they will give you alarm because it's too low. You can use this to control the pump turn on or pump turn off. And if the liquid level is too high, you also don't want them to go too high. So they actually will control certain amount of liquid inside this tank. If too high or too low, they will give you the warning signal. They will stop the pump to work. Because those probe you put down there depends on how long is the probe or how deep you put into the container. They're not gonna give you a continuous measurement. They will only tell you if the liquid level is too low or the liquid level is too high, or in here you can turn the pump off, or in here you can turn the pump on. So it only works between the two probes. So if you have two probes, it can only give you the measurement if the both probe is immersive inside the liquid. So that's where they call it's limited to pouring measurement, and it only can be used in conductive liquid only. So those probe, it's only if the liquid is not conductive, you cannot use them. So here's something important. The disadvantage use conductive probe is they are limited to point measurement only, and only can be used with conductive liquid. How many people still waked up there? So, okay. Hey, then you will get this question right? Let's see, another one. This one we're talking about capacitive probe sensor. They are used to provide a continuous level measurement. But the tank wall of those capacitive probe have to be electrically conductive, so they're gonna use them as one of the plates. They are based on the capacitance. Oh, Hayden, you are the good guy. So they have a two conductive plate with a dielectric between them. So this liquid is not conductive. The plate are probe project from the housing and the electrically conductive tank wall. So this will be one side of the plate. The probe will be another plate. The liquid will be non-conductive liquid. The capacitance value of the capacitor is proportional to the level of the liquid because the air, we have a different, we call that permittivity than the liquid down here. The liquid will have a different permeability, permittivity. So that's the K value in the formula we're talking about before. So capacitance equal to K times A over D. When tank is empty, dielectrical is the air, the capacitance is low. When the level of the liquid rises, the capacitance will become high. So based on that K value to change the capacitance, so this capacitive probe sensor can have a continuous measurement. And for the capacitance for here, the signal condition unit gonna change into standardized or electrical signals. And from that signal, you can convert it to liquid level signal. If you're using conductive liquid, you have to be putting insulation material on the probe or even the tank internal walls. There are different variations. If the wall is not parallel to the probes, you have to put using two probes, or if the tank container is non-metallic, you also need two probes. The capacitance of a capacitive sensor . 8 decrease. That's right. The problem of a capacitive level sensor must be coated with insulating material. Its liquor is be good. 2 probe project from a housing capacitive must be used when the wall of the container are C. Both. Okay. So here the thing in the book they also talking about this capacitive probe, and I guess that program show you pretty good. Also, we can use gamma ray. They usually sending radiation through the liquid. Then you have a receiver down here. Depends on the liquid level. This radiation travels through the liquid. We also tell the liquid level, but this one is pretty limited usage. It's very accurate, but you can, because the radiation is dangerous to human and environment, so got to be really careful. The ultrasonic system, it just sending an ultrasound signal. When it reach the liquid surface, we bounce back that signal. Then when it bounce back, you can calculate the time for the signal to travel to there and bounce back. Then you can calculate the distance down there. That's how you can know the level of the liquid down there. See. There's a certain thing will affect the time for the speed of the sound pulse to reach there, the temperature, humidity, or density of the air, if this is a compressed area or it's just open to the air. I think I have another one to show you because this is an important one for the ultrasonic one. Ultrasonic sensors. They use a high frequency sound wave to detect object. So they're sending a sound wave, and when the sound reaches the target, it will bounce back. Then it just detects the time for them sending out and bounce back to detect the distance. The ultrasonic waveform is we cannot hear because it's above our hearing range. There's a pressure meter switch and the analog sensor. So they use these lights to turn on and turn off to just detect if the target is close to the source or not. So those is the analog sensor, how he can detect the distance from an object. If you guys in the school, we actually have the lab to, in this automatic control, we actually have the lab. You can use an ultrasonic sensor to do a measurement of the water in the tank. But the online one, you probably cannot do it. So for ultrasonic sensor, you always have to do a calibration. You want to know what's the maximum distance you want to detect, what's the minimum distance you want to detect. You have to set those things up with whatever, if you have a voltage signal 0 to 10 volts or current signal 4 to 20 milliamps. Usually those sensors have some adjustment back. You can adjust them. Don't need to do this quiz. This one have a mistake in there. But so for ultrasonic sensor, you need to understand the basic. It's sending out a high frequency sound waveform, and when it reaches the target or reach the liquid level, it's gonna bounce back, and by calculate the time sending out and bounce back, it can measure this distance down there. By measure this distance, so they know the whole tank distance, so they can display the tank liquid level in the tank. So that's also good to know for the ultrasonic sensor how it works. Oops. The radar system. The radar system is instead of sending a sound signal, they sending electromagnetic signal as a radar. So the same idea. They measure the time is sending out and the receive bounce back, so they can calculate the distance. This conductive probe, we already watched some animated place. So you can use one or you can use two, or you can use multiple to testing the measure the liquid level. I think that's it for this one. Okay. So that's everything for module 3. In the module 3, as we go through, there's a few things you need to pay attention to, and not all of them, but the important, the basic thing, if you get those, you should be doing fine. We're okay. Should we go to module 4? So module 4 is a small module. It's for flow measuring. So we have a flow transducer, flow transmitter. There's 3 different ways. There's more than 3, but in here we're only talking about 3 different ways to measure the flow. One is a volumetric flow rate meter. It's the most common, it's the most useful. And then another one is called a mass flow rate meter. And the last one is called the total volume meter. In here, it also says you can read the whole module 4 to get more detail. First is volumetric flow rate. They call it a head flow meter. They use the pressure drop between the 2 points to calculate what's the volumetric flow rate. The flow rate is proportional to the square root of the pressure difference. That's a way to measure the flow rate. And here is one of the formula they're using. They said a volumetric flow rate equal to the velocity of the speed, or the velocity of the fluid moving inside the pipe times the cross-section area of the pipe. So this is an important formula. You have to, we're not going to ask you to do the calculation, but you have to understand how they use this formula to find out the flow rate and what's each letter in here indicates. Yes? No? Are you guys all falling asleep in my class?
Nope.
No? Okay, now I'm gonna do one thing. I'm gonna stop sharing the screen with you. Okay, I just gave you a formula. How many people knows what those 3 letters in that formula means? Each letter in the formula. I don't think the formula is in your book, so Yeah, don't.
Are you talking about the one you just gave us where Q volumetric flow rate in units of volume per unit of time, V is velocity of the fluid, A is cross-sectional area of the pipe, or the Q is
Yeah, Hayden, you are a good student. Now I can see you are a good student. Yes. So Q equal to V times A. Q is the volumetric flow rate, and V is the velocity, and A is the cross-section area. So you better know that formula. Now I know who's the good student in my class, right? Should I give you some extra bonus mark? Yeah. Yeah, good student should get some extra bonus mark. So there's a different formula, so they can calculate that the flow rate is also it's a differential pressure across the plate. But the second one is not so important as the first one, so you better know the first one. One thing here is this float. Do you guys know what will be considered as a float? Anyone? Yeah, something can move, right? So is the water a float? Okay, be careful, Corlin. A gas is actually a float. So what would be considered as a fluid? Liquid, gas, vapor. Anything can be easily move or flows. Yeah, so oil is a liquid, right? So everything here will be considered fluid. So if I gave you a question, I said, let's go there yet. So which of the following is fluid? A, B, C, D, E, F, all of above, none of above, I don't care. Which answer you're gonna choose? Plasma? Not 100% sure what's the plasma's definition. If it can move, then yeah, so Ifan, you choose F, right? So anyone choose F, gonna get a version F exam. You want the challenge? Okay. You will get it. I'll make a version F exam. You can only get below 30%. Okay, so we come back to here. Volumetric flow meter. There's 3 different type. One is called Orifice plate. They put something inside the pipe to make a smaller opening down there. There's a different type of opening where they will put. This one concentrate one we put it right in the center. This eccentric and this segmental they usually put at the bottom. It depends on what type of the flow you inside. Like say if you have a liquid and the gas mixed, they will try to measure the liquid flow rate. They will use those type. If it's a full of liquid, the whole pipe is filled with the liquid, then they will use the concentric one. They all have their own advantage and disadvantages. Some are more expensive, like this one. It will be more expensive one, but they will be very accurately measure them. And this one will be the most cheap one, but also they will be depends on the flow rate. If your flow rate is really low, then this one cannot give you very accurate measurement. And but also same thing for this one. If you want to do the maintenance or you want to do the repair, the cost gonna be way higher. So those are 3 very common ones for them. And we're just going to give you some introduction for them. They base on the differential pressure to measure the flow rate. So this Orifice plate, they put inside the pipe. It's gonna blow the liquid flow in there. You will creating a smaller opening in the center. So when the liquid goes through here, they will change the speed of the liquid, and the change of the speed will causing the pressure change between the upstream and the downstream. So your upstream will have a high pressure, the downstream will have a low pressure, and the difference between those pressure we can use to calculate for the flow rate, like the formula, one of the formula they gave before. For this one, I actually have something to explain to you. Just give me a second. Yeah, so we finish this one, we probably can go for lunch. So this is our Orifice plate flow meter. Industrial process, monitor the rate and flow through the pipe. This is the flow meter. This is the on-off valves down here. So here's the valves, here's the flow meter. You have flow meter at different location. The fluids including liquid, gas, and the vapor. Instrument designed to measure the flow, fluid providing information about the system. Orifice plate flow meter. Plate with a hole in the center to reduce the area through which the flow can flow. So the only center part, you block the flow down there. The mass enter the pipe equal to the mass leaving the pipe during the same period of the time. velocity of the fluid that leave the orifice is faster than the velocity of the fluid that approaching it. As the velocity increase, the pressure will decrease. So there's more pressure on the incoming side because you try to limiting the liquid flow. And on this side, you suddenly opens it up, so it will become more freely to go. That's why they were creating the different pressure down here. So there's a way to calculate exactly for the different pressure. They can calculate the flow rate. The differential pressure across the orifice increase as measured by the sensor on each side. So you have a pressure sensor on each side. Square root of the pressure difference. So that's the one we're talking about. So when flow rate doubles and the pressure increased by 4 times. A special device, it can produce an output. So as the velocity of flow increases, the pressure exerted on the surface is, who still wake up? Be good. Flow rate of pipe increases, the pressure on the outgoing side is so when the flow rate of flow through the pipe increase, the pressure also increases, but not as much as the incoming side. It's okay. Flow through the orifice reduced to half. The different pressure across reduced to reduced by 4. Because it's to the square of that. So if you take the square root of 4, give you 2. Okay. Let's go for lunch. We come back at 11:30. We good?
Yep.
Okay, see you guys at 11:30.